Hello, my name's Dawn and I'm going to tell you about this fantastic substance called dry ice. We're going to try and work out what it's made out of. Now I've got some normal ice here and some dry ice here. First of all, we're just going to have a look and see what makes it look different. So that is my normal ice that we make out of water. Whoop, and this is my dry ice. Now you can see it makes a noise, which is a very weird thing, especially when you touch it with something metal. And our other ice doesn't do that. One thing different. And now have a look. Now it's warmer in here than the melting point of ice. It's definitely above 0 degrees. And if you have a look at our liquid ice, so this one here, this water ice, you can see it's starting to melt. And this water is coming off it. And this means that this is actually starting to turn from a solid, our ice, into a liquid, our water. However, if we look at our dry ice, it is actually starting to turn from a solid, but it's not going from a solid to a liquid. And that means that even as this changes state, so it's state of matter from solid, it doesn't actually create any liquid. So that underneath it, you can see that the plate is staying dry, which is why we call this dry ice. So we've got our water ice, our wet ice, and we've got our dry ice. We're going to find out what this is made out of. Now, the other difference between our dry ice and our wet water ice, what happens to water ice when you heat it up? It turns from a solid ice into liquid water. Now, let's see what happens to this dry ice when we heat it up. Now, it's really hot in this room. So it was really cold inside the flask, and now it's sitting inside here. And if this was normal ice warming up, it would turn into a liquid, wouldn't it? But if you look very carefully, you can see that it's not turning into a liquid. There is no liquid in the bottom of this container at all. In fact, it's turning straight into a gas. And that's the amazing thing about dry ice. It doesn't melt. It actually does something called sublimation. It sublimes. And that means that it goes from being a solid straight into being a gas, missing out the liquid altogether. Now, you might think that this is actually just a fake thing. So I'm going to prove that this is actually a gas here, and it's a special type of gas. And we're going to try and work out what gas it is. So I've got here some matches, and I'm going to light one of these matches. We're going to see what happens when I pour this gas, which is this dry ice that is sublimed. We're going to see what happens if I pour it over the match. Now, matches need oxygen to be able to stay alight, and without oxygen, they will go out. Now we're going to see if this is oxygen. If this is oxygen, it's going to go really big, or whether it's something that doesn't help the flame. Now can you see that this is actually going downwards? I'm pouring it, so it pours a bit like a liquid. So it is a gas, but it's a gas that's sinking. It's going downwards. And what did it do to that flame? It turned it out. So this gas must put out fire, so it can't be oxygen. Now we're going to try it on a bigger scale. Now we're going to do this on a bigger scale so you can see it a bit better. And to do that, I'm going to warm it up. So if you warm up a reaction, it happens much faster. If you think about ice, if you want it to melt really quickly, you warm it up. So what I'm going to do is, with some of the dry ice that's in here, I'm going to add some warm water, and that will make it actually sublime much quicker. So let's put a bit more of this dry ice in here. So I'm going to put a bit more dry ice in here. There we go. And then I'm going to put in some warm water, and I just want you to watch. Obviously it's going to be liquid on the bottom of this, but it's going to be the water. It's not going to be any of this liquid from our dry ice. So when I pour it in, watch the gas that's created and see which direction it goes. You ready? you see the way that it is falling down as it goes out of our bowl? So this gas is very heavy. And you see it's making a really cool effect. You might have seen this before on television. So this cool effect is making this gas sink down. So this is a heavy, heavy gas. Ooh. Even when I blow it, it still sinks down. Now, what we're going to do is we're going to see if we can work out what gas this is. Now, to find out what this gas is, we're going to use it to fill up a balloon. So I'm going to pour a bit of dry ice into this balloon. And I'm going to seal up the end once I've got it all in. And then we're going to wait. And as it sublimes, turns from a solid into a gas, it should inflate our balloon. Now, if I wanted to speed this up, what do you think I could do, apart from press fast forward on the video? I could heat it up. So I'm going to get some hot water, and I'm going to put it in it and see if it goes any faster. Can you see it expanding? So now I've got my pink balloon, which was filled up by the dry ice. And this is just a normal balloon that I've blown up, so it's full of air. What we're going to do is to see the difference between these two gases is we're going to drop them to see what happens. Now, if they're both filled with a gas which weighs the same, then if you drop them, they will fall at the same rate and the race will be equal time and they'll both land on the ground at the same time. If the gas that's made from the dry ice is heavier, it will fall faster. If it's lighter, it will fall slower. So let's see. So ready, 1, 2, 3, go. Let's do it again. And again, just in case. 2 to the pink, 2 to the dry ice. One last time. And that's 3 to the pink. So that means our gas, which is made from dry ice, is heavier than air, which means it can't be air, but it might be one of the gases that makes up air. Now, the last experiment to find out what this gas actually is, we're going to use an indicator to tell us what happens when we actually mix it with water. So inside these two glasses, they're identical. They've got water in them and they've got indicator. And the indicator is a pH indicator. It tells us whether this is acid, and acid is what you have if you have Tangfastics, if you go with your mouth, or lemon juice, that's acid, or alkali, which is the opposite. So at the moment it's green, which means it's not acid, it's not alkali, it's actually in the middle, which is neutral. So what I'm going to do is I'm going to put dry ice into one of these, and not dry ice into the other, so I'm going to leave that as a control so that we can compare the colours between the two glasses. Because if this is the gas I think it is, it will react with the water and dissolve to form an acid called carbonic acid. And if that happens, this should change colour from green, it might go a bit lighter, it might go to yellow, and if we're lucky, it might go slightly red. So that's what you're looking for. And just so that you know it looks different, you can compare it to the glass next to it. So here we go. Whoa, that was pretty quick and pretty comprehensive, I'd say. So that's what it looks like when it's neutral, when it's just water. And that orange colour tells us that it's an acid. So this gas that is actually a solid when it's dry ice is carbon dioxide. And the carbon dioxide is dissolved in the water, reacting with it to create carbonic acid. And that carbonic acid has turned our indicator from green to orange. So we've actually made an acid out of our gas. Cool colour changing, isn't it? Now let's see if we can catch some of that carbon dioxide gas inside a bubble. Oh, bother. Oh, still going. Oof! There we go. Now I'm going to make some bubbles filled with carbon dioxide. Hello, my name's Dawn and I'm going to tell you about this fantastic substance called dry ice. We're going to try and work out what it's made out of. Now I've got some normal ice here and some dry ice here. First of all, we're just going to have a look and see what makes it look different. So that is my normal ice that we make out of water. Whoop, and this is my dry ice. Now you can see it makes a noise, which is a very weird thing, especially when you touch it with something metal. And our other ice doesn't do that. One thing different. And now have a look. Now it's warmer in here than the melting point of ice. It's definitely above 0 degrees. And if you have a look at our liquid ice, so this one here, this water ice, you can see it's starting to melt. And this water is coming off it. And this means that this is actually starting to turn from a solid, our ice, into a liquid, our water. However, if we look at our dry ice, it is actually starting to turn from a solid, but it's not going from a solid to a liquid. And that means that even as this changes state, so it's state of matter from solid, it doesn't actually create any liquid. So that underneath it, you can see that the plate is staying dry, which is why we call this dry ice. So we've got our water ice, our wet ice, and we've got our dry ice. We're going to find out what this is made out of.